voltage of a battery supplying power to a prime mover without overcurrent protection is 120 volts. This specific voltage level is relevant because it interacts with the overall electrical system's design and safety features. Firstly, understand what a prime mover is. A prime mover is essentially the initial source of mechanical power for a system. Examples include engines and motors. The battery provides the initial electrical energy to start or operate the prime mover. Secondly, without overcurrent protection, the circuit becomes vulnerable to damage from excessive current flow. Overcurrent can result from short circuits, overloads, or other electrical faults. Thirdly, the selection of 120 volts for this application indicates a design choice related to the specific requirements of the prime mover and the associated electrical system. It suggests that the prime mover is designed to operate efficiently within this voltage range. This voltage also influences the types of components and wiring used in the system. Choosing the correct voltage is critical. An incorrect voltage can lead to inefficient operation, damage to equipment, or even create safety hazards. For example, using a battery with a voltage too high can damage the prime mover's electrical components. Conversely, a voltage that is too low might not provide enough power to start or operate the prime mover effectively. The absence of overcurrent protection highlights the importance of other safety measures in the system. These measures might include fuses, circuit breakers, or other protective devices located elsewhere in the circuit. It also emphasizes the need for careful system design to minimize the risk of overcurrent situations. When dealing with electrical systems, especially those involving prime movers, it is crucial to adhere to established safety standards and regulations. These standards provide guidelines for selecting appropriate voltage levels, implementing overcurrent protection, and ensuring the overall safety of the system. Understanding the relationship between battery voltage, prime movers, and overcurrent protection is essential for anyone working with electrical systems. It involves not only knowing the correct voltage levels but also appreciating the importance of safety and regulatory compliance. In practical applications, the specific voltage requirements of a prime mover will depend on its design and intended use. Always refer to the manufacturer's specifications and relevant electrical codes to determine the appropriate voltage level and necessary safety precautions. The significance of the 120 volts rating in this scenario lies in its connection to the overall safety and functionality of the system. Without overcurrent protection, the system relies on other design elements and safety measures to prevent damage and ensure safe operation. The selection of 120 volts is also influenced by factors such as the type of prime mover, its power requirements, and the available electrical infrastructure. In some cases, other voltage levels might be more appropriate depending on these factors. Always consult with qualified electrical professionals and adhere to relevant codes and standards when working with electrical systems. When considering battery voltage in relation to prime movers, remember to evaluate the entire electrical system as a whole. This includes the wiring, components, and protective devices. A well-designed system will incorporate multiple layers of protection to minimize the risk of electrical hazards. In addition to voltage, other electrical parameters such as current and power are also important considerations. These parameters must be carefully matched to the requirements of the prime mover to ensure optimal performance and safety. Always use appropriate measuring instruments and follow safe work practices when working with electrical systems. Electricity can be dangerous, and it is important to take precautions to avoid injury. When troubleshooting electrical problems, start by identifying the symptoms and then systematically investigate the possible causes. Use a process of elimination to narrow down the problem and then take appropriate corrective action. Always disconnect power before working on electrical equipment. This will help to prevent electric shock. Use insulated tools when working with electricity. This will help to protect you from electric shock. Wear appropriate personal protective equipment, such as gloves and safety glasses, when working with electricity. This will help to protect you from injury. Follow all safety rules and regulations when working with electricity. This will help to ensure your safety and the safety of others. Finally, be aware of the potential hazards of electricity and take precautions to avoid them. Electricity is a powerful force that can be dangerous if not handled properly. The voltage of a battery supplying power to a prime mover is a critical factor in the operation and safety of the system. Understanding the principles and practices outlined above will help to ensure that you can work with electrical systems safely and effectively. It is the combination of the correct voltage, proper overcurrent protection, and adherence to safety standards that ensures a reliable and safe electrical system for powering prime movers. Electrical systems can be complex and require careful consideration of various factors. Always seek professional guidance when necessary and prioritize safety in all electrical work. The 120 volts battery supplying power to the prime mover interacts with various components in the system, and a fault in one area can affect others. The electrical characteristics of the battery, such as its voltage stability and internal resistance, can also impact the performance of the prime mover. A battery with a stable voltage and low internal resistance will provide a more consistent and reliable power source. When designing or troubleshooting electrical systems, it is important to consider the overall system impedance and its effect on voltage drop. Excessive voltage drop can reduce the performance of the prime mover and other electrical components. To minimize voltage drop, use appropriately sized wiring and minimize the length of conductors. Also, ensure that all connections are clean and tight. Overcurrent protection is essential for protecting electrical equipment from damage caused by excessive current flow. Fuses and circuit breakers are commonly used for overcurrent protection. These devices are designed to interrupt the flow of current when it exceeds a predetermined level. The size and type of overcurrent protection device must be carefully selected to match the characteristics of the circuit and the equipment being protected. Improperly sized overcurrent protection can result in nuisance tripping or inadequate protection. Grounding is another important safety measure in electrical systems. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip overcurrent protection devices and prevent electrical shock. The grounding system must be properly designed and installed to be effective. Regular inspection and maintenance of electrical systems are essential for ensuring their continued safe and reliable operation. Inspection should include checking for loose connections, damaged wiring, and malfunctioning components. Maintenance should include cleaning and lubricating components, testing protective devices, and replacing worn or damaged parts. The specific voltage is selected based on the design criteria for the prime mover and is selected by the manufacturer. It is also important to note that the absence of overcurrent protection does not imply that there are no safety measures in place. Other protection mechanisms, such as fuses or circuit breakers located upstream in the electrical system, may provide overcurrent protection for the prime mover circuit. Additionally, the prime mover itself may have internal protection features to prevent damage from overcurrent or other electrical faults. However, the lack of local overcurrent protection on the battery supplying power to the prime mover does highlight the importance of carefully considering the potential risks and implementing appropriate safety measures. This could involve using heavier gauge wiring to reduce the risk of overheating or installing additional protection devices in other parts of the circuit. It is also important to regularly inspect the battery and wiring for any signs of damage or wear, and to replace them as needed. In addition to the electrical aspects, there are also mechanical considerations to keep in mind when working with prime movers. Prime movers often involve rotating machinery, which can be hazardous if not properly guarded and maintained. It is important to follow all safety precautions when working around rotating machinery and to ensure that all guards are in place and functioning properly. When selecting a battery for a prime mover, it is important to consider the starting requirements of the prime mover. Some prime movers require a high surge of current to start, while others require a more gradual increase in current. The battery must be able to provide the required current without excessive voltage drop. It is also important to consider the operating temperature range of the battery. Some batteries perform poorly in cold temperatures, while others are better suited for hot environments. The battery should be selected to operate reliably in the expected temperature range. When installing a battery in a prime mover, it is important to follow the manufacturer's instructions carefully. The battery should be securely mounted to prevent it from moving or vibrating, and the terminals should be properly connected to the electrical system. It is also important to ensure that the battery is properly vented to prevent the buildup of explosive gases. Regular maintenance of the battery is also important for ensuring its long-term reliability. This includes cleaning the terminals, checking the electrolyte level, and testing the battery's state of charge. A well-maintained battery will provide reliable power for the prime mover and help to prevent unexpected breakdowns. In conclusion, the voltage of a battery supplying power to a prime mover without overcurrent protection is a critical factor in the operation and safety of the system. It is important to carefully consider the design requirements of the prime mover, the potential risks of overcurrent, and the importance of implementing appropriate safety measures. By following these guidelines, you can help to ensure that the electrical system is safe, reliable, and performs as expected. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. The 120 volts requirement is a cornerstone of safe and efficient operation.